Okay, ladies and gentlemen, along with logarithmic functions, we not only need to be able to deal with them algebraically, we need to be able to deal with them graphically. Now, as a real quick reminder, let's graph an exponential function. And our exponential function of y equals 2x. If I have that, that means it's going to go through 1, and it's going to be curving basically up like this. Now, the whole point of having logs is because we want to convert from exponential form to logarithmic form, and logarithmic form back to exponential form. What we really end up with is, remember, if we have x squared, we square root. If we have square root, we square. They're inverse operations of each other, and so the graphs are also inverses. In the same way, exponential functions, their graphs are inverses of logs, and logs are inverses of exponentials. So if I want to find the inverse of this function, as always, to find an inverse, we switch x and y. Fine. And now we apply our log rule to get y by itself, so we say log base 2 of x equals y. Well, when I go to graph that, I need to know, what does this graph look like? Well, anytime we have inverse graphs, we know that we flip this graph over the line y equals x. So, in doing inverses of exponentials, instead of going up 1, we're going to go over 1. So instead of 0, 1, it's 1, 0. And so in this case, it's going to look like that. And those two ought to be nice matches of one another. So I simply take it and I flip this graph over the line y equals x. Now, just in case you don't believe me, went ahead, graphed it up in my calculator, and it does exactly this. If I go and try to put in 2 raised to the x and graph that, you should see that they are nice matches of one another. So we have this situation going on here. Now, so since the graphs are inverses, we simply flip them over the line y equals x. Well, that's fine and dandy too, except that now that we have this whole log that we can graph, we can do more stuff with it. If I have log base 2 of x minus 1 plus 3, well, in the same way that we were able to shift the other graphs, we can shift this graph. So if the standard log graph goes through 1 and arcs up, this says minus 1 means over 1. So now it goes through 2. And it says up 3. 1, 2, 3. So now my new point is over 2 up 3. And I can graph it just like that. If I have another example, example 2 here, and I have y equals negative log x plus 4, I want to show you something very key. The standard graph of log of x, base 10, base 2, whatever the base happens to be, is this graph right here. Plus 4 means I go up 1, 2, 3, 4. My new point is right here. So it looks like that. But the negative out front means it's flipped vertically. So my final answer is actually this. Now, the reason it doesn't flip over the x-axis is because the negative is only in front of the log. If I had a situation where y equals log negative parenthesis log x plus 4, now I would have this, that when the negative is given away, it's actually going to turn that plus 4 into a minus 4, And so now that goes down below because the negative affects both the 4 and the log. But up here, the negative only affects the log, not the 4. Okay? So, all of the same shifting rules apply to graphing logs as they do to graphing exponentials. So make sure you can do that as well. Remember, how do we get to logs? They are inverses of exponentials.